Arc length. Okay. This is a very straightforward formula. The only thing that you have to remember is that the value of the angle they give you has to be in radians. Okay? So the angle has to be in as a radian measure. That's all you have to know. If they've given it to you in degree form, you need to change it to be a radian measure to be able to use this formula. Now, we're considering a sector. Do you remember a sector is a piece of pie? So the blue thing is a sector. Okay? So if we're considering that sector, we can see that it's got radius r, and I'm going to call this sector, this arc length here, L. So if I were to show the ratio of the length L divided by the circumference, so this portion here compared to the whole circumference would be the same ratio as theta over 2 pi. Why is it over 2 pi?
Because it's half. It's like a half.
It's not a half area. It's like a 360 thing. Okay, so if we've been talking degrees, this would be a 360. But because we've said it's going to be in radians, that's why it's over 2 pi.
Wait, but why are we doing 360 when this is not?
Because you know how it's a portion of the whole amount. So we're saying that this length compared to the whole circumference would be the same ratio as this angle compared to the whole circle. Yeah? Okay, so that's the first sheet. Oh, no, is there something underneath it? Oh no, I'm going to write all you guys. If you write some stuff. Alright, so if I want to, what's the formula for the circumference of a circle?
2 pi r. Pi r squared.
No, you were right, 2 pi r. Okay, so L would be 2 pi r. Okay, so all I've done is change the circumference to the actual formula. What do I do then to try and find L? Cross multiply. So I just need to bring this baby up to the other side. So I've got theta over 2 pi multiplied by 2 pi r. What can we see happens then? We're going to pretend that that's over 1. What cancels out?
2 pi.
The 2 pi and 2 pi. So we're just literally left with theta multiplied by r. Yes, you're happy with that? Now that is the formula for the arc length of a sector. So in your formula booklets that you will have treasured, you will find and see that formula. Okay? What did I say is the most important thing about this formula? About this value here? Has to be in radians. Okay? Majority of questions will be given to you in radians, but if it's not, you need to change it to radians. This is the sector area. Okay? So this is the area of it. So not the arc length, but the area of it. We've got the same principle. I'm talking about the area sector, so the blue area. So this is part here. All of this. Okay, so that area divided by the whole area would be equal to theta over 2 pi. Again, we're talking 2 pi because it's in radians. What's the formula for the area of a circle? Pi r squared. So we've got A over, oh sugar, you wrote the wrong one. Pi r squared equals theta over 2 pi. Similar thing we did just now. So A equals theta over 2 pi multiplied by pi r squared. Secretly over 1. What can we cancel here? Just pi. So we've got A equals theta r squared over 2. Now that looks a bit weird. How it's normally written is that area is 1/2 theta r squared, or r squared theta. But all means the same. Pardon? Alright, again, you get given that. You don't have to learn it. You need to just practice questions with it. Okay? And leave our things on the next page. Alright, find arc length L and area A of the sector of a circle, radius 7, and sector angle 2 radians. So what I would suggest you want to do is just draw a quick diagram. There's my sector. It's got radius 7, so this value here is going to be 7. Someone needs to turn their phone off. So this value here is 7, and the sector angle is 2 radians, so it's just 2. So my arc length, what do we do to find the arc length? Theta r, so what we're going to have here? Multiplied by 7, which is 14. Okay, this unit was in centimetres, therefore the arc length would also be centimetres. That's it. Simple, isn't it? Yes? Like, distressingly simple. Some people do it and go, I can't believe I've just given them give us marks for that. But it really is that simple. Okay? It's really, if you get these ones, you're like, area. So then remember that was 1/2 r squared theta. So for this case, it's A equals 1/2. This time it's r squared, so it's 7 squared multiplied by 2. This could look well beyond the non-calc paper, so we've got to think sensibly. We've got 1/2 multiplied by 7 squared multiplied by 2. Tell me what's a good thing to do. In this question, what can you do? Well, what about this and this? Yes, because I've got 1/2 multiplied by 2, what happens? They cancel each other out, so it just becomes 1. Yes? So then my answer is just going to be 49. Do you see that? Yeah. So, everyone happy with that? So I've got 1/2 multiplied by 2. Obviously, yes, I'm getting there. So, yeah, my units would be centimetres squared. That's a squared sign. Okay, question 2. Find the arc length L and area of the sector of circle radius 5, sector angle 150. Give the exact answer in terms of pi. Again, we've got a diagram. We've got radius 5, sector angle 150. So the first thing we have to do is change our angle to be a radian measure. Do we remember how to change from a degree to a radian? What do we have to do with it? Multiply by pi over 180. 180. Okay? So remember, going from a degree to a radian, you multiply by pi over 180. So we need to then cancel these out, so I can divide both this and this by 10. I've now got 15 and 18. What number goes into both 15 and 18? 3. So I'm going to divide this, so this becomes a 5, and this becomes a 6. So I've got 5 pi over 6. Okay, so my 150 degrees has become 5 pi over 6. We're leaving our answer in terms of pi, so we're going to leave it like that. Remember, it could be on the non-cap paper. So we're now trying to find the arc length. So L is going to be 5 multiplied by 5 pi over 6. Remember 5 is 5 whole ones. So that's just 25 pi over 6. And then we've got the area is a half r squared, so that's 5 squared meter. So we've got 1/2 multiplied by 25 multiplied by 5 pi over 6. I've kept my 25 up in the air because I know it's a whole number, so that's over 1. So I've got 1 multiplied by 25 multiplied by 5. What's 5 lots of 25? 125. I'm multiplying, not dividing. So that's pi, 125 pi, and 2 multiplied by 1 multiplied by 6. 12. Okay, so that's your final answers. Alright, so this is just literally a summary. You get given these formulas and to learn them. And just remember, if you were given a diagram like this, and told that this was, for example, 1.2, and you were asked to find either the area or the arc length of the shaded part, what would you have to do first of all? How do you figure out how much the entire thing is? Remember to use these formulae, what you need to know the angle of the sector you're interested in, yes? But I know this angle here, so how am I going to work out this angle on this side? Right, so you've got the right idea.
You make 360 a radian.
Yeah, so what, remember we just talked about it, what would 360 be in terms of radians? 2 pi, okay? So to find this angle here, you would do 2 pi subtract 1.2. Okay, that's going to give you that angle. And then you can stick it in wherever you need to. Now if it was something like 1.2, it would more likely to be on the calculator, so you could actually type in 2 pi, literally 2 times pi, and then subtract 1.2 and it gives you a value. Okay? Otherwise, you would leave it in terms of pi, just they would be nicer numbers. Okay, so just remember, if it's on paper 1, most of your answers can be left in terms of pi, or square roots, or whatever it is. Okay, you wouldn't be expected to work out stuff like that on the paper 1.